Okay, this is the third video in the inequalities videos. Here is another example. Now you've already seen a very similar question to example 3, part A and B. However, part C is different to other things that you've seen. So if you could please attempt example 3, question A, and you should be able to do question B as well, because that was similar to the first example that we did. And then you can restart the video once you've done those, okay? Now, when we proved this earlier, to prove that a plus 1 on a is greater than or equal to 0, we started off with a minus 1 squared is greater than or equal to 0. An alternative, there's actually a few ways that you can do part A. I'm just going to show you another way here. Instead of starting with a minus 1 squared, so last time we started with a minus 1 squared is greater than or equal to 0. We expanded, we divided through by a, providing you can do this if a is positive, and then we came up with that expression. But another way you can do this is you can start off with the square root of a minus 1 over the square root of a squared is greater than or equal to 0, because when you square this, you'll end up with your a plus 1 on a plus 2, and then just take the 2 to the other side. So then completing this, expanding this perfect square, you would get square root of a squared is a minus 2 times root a times 1 on root a plus 1 on root a squared, which is 1 on a, and that's greater than or equal to 0. And therefore you'd get a plus 1 on a. Now these cancel here, leaving 1's. You would get a plus 1 on a is greater than or equal to 2. So that just shows you an alternative method there for doing part A. Now for part B, you have to deduce that if A, B and C are positive, then A plus B times 1 on A plus 1 on B is greater than or equal to 4. Now we know that something, A plus its reciprocal, is greater than or equal to 2. So what we're going to do, we're going to start off with this. So we've got A plus B times 1 on A plus 1 on B. And we have to show that that is greater than or equal to 4. Now, you can start by expanding that, okay? So A times 1 on A is 1, plus you would get A on B, plus B on A, plus B times 1 on B is 1, which means that you would get 2, 1 plus 1 is 2, plus A over B plus B over A. Now notice that A over B and B over A are reciprocals of each other. So therefore, you could write this as 2 plus, you could call this capital A plus 1 over capital A, where capital A is A over B. You could do it like that, just to show that you've clearly got A plus 1 on A is greater than or equal to 2, so therefore that would be greater than or equal to 2 plus, now this bit here is greater than or equal to 2, so it'd be greater than or equal to 2, so therefore your expression here, sorry, I'm just off the screen. So therefore your expression A plus B times 1 on A plus 1 on B is clearly greater than or equal to 4. So that just shows another way of doing this question as well, slightly different to what I did in example 1. Then you also have to deduce that A plus B plus C times their reciprocals are greater than or equal to 9. So that's still part of part B. Now we just start off with the left-hand side, A plus B plus C times 1 on A times 1 on B plus 1 on C. You can expand that and you would get 1 plus A over B plus A over C plus you would get B over A plus B over B, which is 1, plus B over C, and then you would get C over A plus C over B plus C over C, which is 1. So you've clearly got 1, 2, 3 plus those groups of reciprocals A plus B on A. Then you've got the reciprocals A over C plus C on A, and you've got the B over C plus C over B. Now clearly again we know that this is something plus its reciprocal again, A over C plus its reciprocal, so therefore that is all greater than or equal to, because this bit here is greater than or equal to 2, we put that this now is greater than or equal to 3 plus 2, plus again this is greater than or equal to 2, so another 2, and this is greater than or equal to 2, so we add another 2, so therefore that whole expression, this whole expression here, is greater than or equal to 9. Okay, now that's part B. You've done something similar to this already. Okay. We'll just speak about equality and when it holds. Obviously, we would have equality here where we've got that this is greater than or equal to 4. You would have equality if here, equality here, if and only if. So we just write that with the double F. So you would have here equality if and only if A was equal to B here. Now it's a bit hard to see it here, but if we come back up here, if here A over B equals 1 and therefore B over A equals 1, then this whole expression, we'd get 2 plus 1 plus 1, which is 4. So that's where we pick up equality if and only if A equals B, because we can actually see it here from this step here, that if A over B is 1 and B over A is 1, then this whole expression here would equal 4, and that's where the equality holds. Okay, so I'll just put here, because it's when A over B is 1. But you just need to write that A equals B. But you can see, if you look back a little bit further in the question, you'll see how you work out where equality holds. And look, it would be the same here. If A over B is 1 and B over A is 1, then this equals 2. And if A over C is 1 and C over A is 1, that would be 2 as well. So again here, equality, if and only if. Now, if A over B is 1, and then when you multiply through by B, you would get A equals B. So equality again, if and only if A equals B equals C. Now, for part C of the question. You hence show that 9 over A plus B plus C is less than or equal to 2 over B plus C plus 2 over C plus A plus 2 over A plus B, which is less than or equal to 1 over A plus 1 over B plus 1 over C. Now, if we look at this inequality, it appears that where we've got this B over 2 over B plus C, 2 over C plus A, suggests that we need to be working with that first bit that we proved in part B, okay, because that first bit in part B deals with, just 2 pronumerals like these ones, whereas this bit here has got the 3 pronumerals, and so does that, okay? So we'll just start off trying to work with this bit here. Now we know that A plus B times 1 over A plus 1 over B is greater than or equal to 4. Okay, now this is A plus B times 1 over A plus 1 over B. So therefore, if I divide by A plus B, I will get that that's greater than or equal to 4 over A plus B. Now, this is okay because we're told in the question that A, B, and C are positive. So therefore, A plus B is positive, and we're dividing by positive, so it doesn't matter about the inequality sign stays as a greater than. We don't have to be concerned as to whether the inequality sign will change, okay? And so therefore, just from here, we've got that 4 over A plus B is less than or equal to 1 over A plus 1 over B. Now look, we're trying to come up with this 1 over A plus 1 over B plus 1 over C. Now we've only got 1 over A plus 1 over B. So what we should do, we should repeat this all again. Look, we've got 3 things here, but 2 here, which suggests we should do all the combinations of A, B, and C and double up. And then we should be able to come up with this right-hand side bit, this middle and right-hand side bit of the inequality, okay? So here we will have equality if and only if A equals B, okay? Now I'll call this equation 1. Now similarly with our result here, remember that you can replace these pronumerals with other things. We're going to do the combination, let's say, of B with C, and then we can do the combination of A with C. So here similarly we've got the B plus C times 1 over B plus 1 over C would be greater than or equal to 4, which means that 1 over B plus 1 over C is greater than or equal to 4 over B plus C. And just writing this the other way around, 4 over B plus C is less than or equal to 1 over B plus 1 over C. So we've got equation 2 here. Notice that the 1 over B is doubled up, so we need the C and the A combination. Again, similarly, we've got that c plus a times 1 over c plus 1 over a is greater than or equal to 4. I'm just going to jump straight to the bottom line. Therefore, 4 over c plus a is less than or equal to 1 over c plus 1 over a. This is equation 3. And now we're going to add these three equations, equations 1 plus 2 plus 3. Notice that all the inequality signs are the same way around. So we've got 4 over a plus b plus 4 over b plus c. Sorry, just running out of room. Plus 4 over c plus a is less than or equal to 1 over a plus 1 over b plus 1 over c. Actually, we've got 1 over a plus 1 over b plus 1 over b plus 1 over c plus 1 over c plus 1 over a. It's actually all of that times 2. Okay. Now, if this is all being multiplied by 2, if I divide both sides by 2, so divide through by 2, I will get 4 over 2, so I'll get 2 over a plus b plus 2 over b plus c plus 2 over c plus a is less than or equal to 1 over a plus 1 over b plus 1 over c. So now I've done this inequality on the right hand side there. Now we need to work on this one here. Now with the 9 here, it suggests, and the ABC, it suggests that we need to use the second result that was proven in part B. Okay. Now, in part B, the second result that was proven was that it was 1 over, just finding it, sorry, yes, in part B, sorry, we had that a plus b plus c times 1 over a plus 1 over b plus 1 over c was greater than or equal to 9. So that was what was proven in part B, the second part of it. Again, this is something times something else is greater than or equal to 9. So if we just divide through by a plus b plus c, we will get this. Now I'm just going to write this the other way around. So therefore 9 over a plus b plus c is less than or equal to 1 over a plus 1 over b plus 1 over c. So therefore, if I just look at this equation here, equation 4, and this equation here, equation 5, if I just line all these up, I know that 9 over a plus b plus c is less than or equal to 1 over a plus 1 over b plus 1 over c. So it's obviously going to be on the left of this inequality. But the problem is I don't know whether this 9 over a plus b plus c goes in here or if it goes here. So this clearly is not going to lead me anywhere at the moment. So we have to try something else. The reason is we need to be able to relate the 9 over a plus b plus c to this middle inequality. We need to know whether this is bigger or less than this inequality here, because we're trying to show that 9 over a plus b plus c is actually less than this inequality, this bit here. Problem is we only know that it's less than that. So what we're going to have to do is try and relate this to this inequality. So what we've got to do, we've got to go back and try something else, okay? So now, if we start with this result here, so we're going to start with this result here, but what we're going to do, actually I'm going to call this just from part B. So if we, from this, we're going to replace A with A plus B, and we're going to replace B with B plus C, and we're going to replace C with C plus A. In this whole expression, what we would get is the following. The thing is, we're trying to introduce a 2 as well, because we're trying to compare this here with this. So if we do this doubling up here, and the other thing is as well, we've got 2 terms here and we've got 3 terms here, which suggests this doubling up. So if we do this now, we'll get A plus B, and we're replacing the B with B plus C, plus B plus C, replacing the c with c plus a, plus c plus a. I don't think it would matter whether you replace the a with the b plus c and the b with the c plus a and the c with a b plus a. I think you would still get all of the you'd still get these double ups the same way, so it wouldn't matter if you didn't choose it exactly like that. Okay, so we've got that times 1 over a plus b plus 1 over b plus c plus 1 over c plus a is greater than or equal to 9. So therefore we've got two lots of this, so two lots of a plus b plus c times this, and we can see we're nearly there now. So therefore if we divide by a plus b plus c and multiply 2 through the bracket here, we get therefore 2 over a plus b plus 2 over b plus c plus 2 over c plus a is greater than or equal to 9 over a plus b plus c. Now we can clearly see that 9 over a plus b plus c is less than or equal to this, so therefore we can just write our conclusion. I just seem to have, and the conclusion, girls, I just don't have room here to write it, will be exactly what the question is. You can put therefore and just rewrite your first line that 9 over a plus b plus c is less than or equal to 2 over all of this, which is less than or equal to that. And the question's completed. And of course we would have equality, so you can write here, with equality if and only if, now if we look at all this, you'll only get equality if and only if a equals b equals c. Okay, because if you look back to say here, and if this was all rearranged and written as common denominators, etc., you would see that quite clearly, that you would only get equality if and only if a was equal to b, which is equal to c. Also, you'd see that you'd get all the same fractions here multiplied by, and when they get multiplied by these, you'd get all the same things here and the same things there as well. Okay. Briefly spoke about the middle link in video 1. This is an example from the Board of Studies. It's example 4 that we're doing. Here we've already proven, I've shown you this proof before, but we have to prove that a plus b over 2 is greater than or equal to the square root of a b. You can pause the video and try that on your own, and then you can restart the video when you're ready. Okay. All right. To do that, we can start with the square root of a minus the square root of b is greater than or equal to, the square root of a minus the square root of b squared is greater than or equal to 0. And so therefore, you can see that you'd need to start with that because you've got the square root of ab, and if you multiply by 2, you've got 2 times root ab, which would come about from expanding this perfect square. So if we expand it, we get a minus 2 times the square root of a times the square root of b, which is 2 root ab, plus b is greater than or equal to 0, so therefore a plus b is greater than or equal to 2 root ab, and dividing through by 2, we get that a plus b over 2 is greater than or equal to the square root of ab. Now that's part 1. Now for part 2. Okay, here we're going to find a middle link to be able to prove that 1 over x plus 1 over y is greater than or equal to 4 over p. Okay, won't be able to do it directly. We'll have to sort of approach it from 2 different ways. Okay, where you'll find a common ground, I suppose. Okay, now we know from this result that if we look back here, that a plus b over 2 is greater than or equal to the square root of ab. Now we're trying to show here that 1 over x plus 1 over y is greater than or equal to 4 on p. So what we're going to do, we've got a plus b over 2. We're going to just multiply by 2, and we get that a plus b is greater than or equal to 2 times root ab. So now if we let a, or replace a with 1 on x, and if we replace b with 1 on y, we can start building this expression up. So we've got 1 on x plus 1 on y. So we're replacing the a with 1 on x and the b with 1 on y. So we get 1 on x plus 1 on y is greater than or equal to 2 times root 1 on x times root 1 on y. And also over this left-hand side, I can just form a common denominator. So y plus x over xy is greater than or equal to, now I would get 2 times the square root of 1 over xy. So I would get 2 over root x on y, because this is 2 times the square root of 1 over xy. Square root of 1 is 1, so you get 2 over root xy. Now I'm trying to come up with something like this. What I'm going to do, I've got an xy here and a root xy there. I suppose they're like terms, so I'm going to divide through by 2, okay? And so I'm going to get y plus x over 2, and I'm going to multiply also by xy. Now, we know that x and y are both positive. It was given to us in the question. So there'll be no change of the inequality sign. So I'm really just swapping these two. So I've got, oops, just running off the page. Sorry about that. So here I just did, because I've got fraction equals fraction, but an inequality sign there. And we know that x times y is positive and that 2 is positive. I've divided by 2 and multiplied by xy. So now, okay, sorry about that. We were also told in the question, coming back up here, that x plus y equals p. So I'm going to replace this here. X plus y is p over 2 is greater than or equal to, now xy over root xy is just root xy, because that's xy and this is xy to the half, and so they're like terms, okay? So we've got this so far. Now we've got, we need to get this 4 over p. We're sort of nearly there. We might just rearrange this. Now, also in the first video, we looked at a rule that if a is greater than b, then 1 over a is less than 1 over b. So if we take reciprocals of both sides, the reason we're doing that is we're trying to prove that 1 over x plus 1 over y is greater than or equal to 4 over p. And here I've got p over 2, so it would be good to have the 2 on the numerator and the p on the denominator. So I'm going to go 2 over p is less than or equal to 1 over root xy. Again, using this rule, okay? Since if a is greater than b, then 1 over a is less than 1 over b, okay? So we've got that. What we could also then do, we need 4 over p, so we'll just multiply both sides by 2, so multiply through by 2, and we would get that 4 over p is less than or equal to 2 over root xy. Now, what we're trying to get, we still don't have it yet. Actually, we just about do, because we know from earlier in the question up here. Actually, if I just write this again, 1 over x plus 1 over y, just coming over here, if I insert another line, is greater than or equal to, here, 2 times 1 over root xy, which is really 2 over root xy. So we know that 1 over x plus 1 over y is greater than or equal to 2 over root xy. And so I can put, just writing this in the same way, that 2 over root xy would be less than or equal to 1 over x plus 1 over y. We can see from up here, okay? And we know that. And so therefore, the 2 over root xy is the middle length. So therefore, 4 over p is less than or equal to 1 over x plus 1 over y, or actually in the question it's written the other way, that 1 over x plus 1 over y is greater than or equal to 4 over p. So therefore we've proven that first result using this middle link here, that the 2 over root xy was the middle link for that question. In this question, I've just had to turn the page. So we've just proven that 1 over x plus 1 over y is greater than or equal to 4 over p. And in the remainder of the question, we have to prove that 1 over x squared plus 1 over y squared is greater than or equal to 8 over p squared. Okay, now if we use the original result so using this result that a plus b is greater than or equal to 2 root ab. So using this original result again with this, we've got that 1 over x squared plus 1 over y squared is greater than or equal to 2 times the square root of x squared times the square root of, sorry, one sec, little mistake there. Sorry, here we're replacing, using that and replacing a with 1 on x squared and b with 1 on y squared. We get that 1 on x squared plus 1 on y squared is greater than or equal to 2 times the square root of 1 on x squared times the square root of 1 on y squared, which means that 1 on x squared plus 1 on y squared is greater than or equal to 2 over the square root of x squared times y squared, which is just xy. So we've got 1 on x squared plus 1 on y squared is greater than or equal to 2 over xy. Now we're trying to show this result up here. Now, if we look at our result from that we've just proven, but we know that 1 over x plus 1 over y is greater than or equal to 4 over p. We already know that from what we've just proven, but if we look back at that result before it was the middle link of that result, we knew that 2 over root xy was greater than or equal to 4 over p. Now this is one of the equations back here on the page before, if you just look back to this result here. Okay, that 4 over p, that 2 over root xy is greater than or equal to 4 over p. So coming back with that, so rather than using this completed result, we'll use this one because it's very similar to that. So we won't use this because that's not going to really help us here, but this will. And because we know that x and y are positive and that p is x plus y and it's also positive, so as xy is greater than 0 and p is greater than 0, we can square both sides. Okay, and we would get that 4 over xy is greater than or equal to 16 over p squared. Okay, now we can compare this. What we can actually do there is divide by 2, okay, because we're trying to get 2 over xy. We're trying to form another link here with this 2 over xy. So if I divide through by 2, I will get that 2 over xy is greater than or equal to 8 over p squared. So therefore, I've got my middle link. So therefore, making sure that it's written the same way as that, and it is, okay? So therefore, we can say that 1 over x squared plus 1 over y squared is greater than or equal to 2 over xy, but 2 over xy happens to be greater than or equal to, yes, 8 over p squared. So therefore, I can say that 1 over x squared, sorry, just running out of room. Sorry, just missed that again. So we know that 1 over x squared plus 1 over y squared is greater than or equal to 2 over xy, but then writing this one here that 2 over xy is greater than or equal to 8 over p squared, therefore 2 over xy is the middle link again. So therefore 1 over x squared plus 1 over y squared is greater than or equal to 8 over p squared. And that result has now been proven. Okay. Another example using this middle link. Okay, this is a HSC example 2003, question 6C. There are actually 4 parts to this question. I've only shown the first 2 parts here. I'll do the others over the page. I want you to actually, you'll be able to do question 1 part easily, and then when you're doing question 2, notice there are 3 things you're trying to to add here, but there's just 2 in this expression, which gives you that idea again of using this result but doubling up, doing it twice and making sure that you replace with A, B and C, but doing it twice through so that you'll have 6 terms and then you'll get doubling up and then end up with the 3 terms. So if you can please try parts 1 and 2, you've used the techniques required for this question in other examples. Okay, and for part 1, we just start with the result square root of x minus the square root of y squared is greater than or equal to 0. So x minus 2 root xy is plus y is greater than or equal to 0. So x plus y is greater than or equal to 2 root xy, and then dividing through by 2. You've done this many times now, it shouldn't be a problem. And then for part 2, suppose that a, b and c are real numbers using this result here. So from part 1, we know that x plus y is greater than or equal to 2 root xy, and if we replace the x with an a4 and the y with a b4, b to the power of 4, we will get that a4 plus b to the power of 4 is greater than or equal to 2 times the square root of a to the power of 4 times b to the power of 4, which means that a to the power of 4 plus b to the power of 4 is greater than or equal to 2a squared, b squared, and I'll call this equation 1. And then similarly, replacing with b4 and c4, we would get b4 plus c4 is greater than or equal to 2 b squared c squared, call that equation 2. And again, similarly, with replacement of pronumerals, we would get that c4 plus a4 is greater than or equal to 2c squared a squared. Now we can see if we add those 3 equations here, if we add equations 1 plus 2 plus 3, we're going to get doubling up. And we're going to get 2 lots of a4 plus b4 plus c4 is greater than or equal to 2 a squared b squared plus 2 b squared c squared plus 2c squared a squared. And now if we divide through by 2, we will get a4 plus b4 plus c4 is greater than or equal to a squared b squared plus b squared c squared plus c squared a squared. Okay. All right, that's fairly straightforward. We'll call that equation 4. Okay. Now for part 3 of the question, I didn't write it down before. The question is to show that a squared b squared plus a squared c squared plus b squared c squared is greater than or equal to a squared bc plus b squared ac, whoops, sorry, just run off the screen there, plus c squared ab. So that's part 3 of the question, to show that this here, this bit here, is greater than or equal to what I've just written there. Again, we're going to have to replace things in this expression, or things in this, with something else to be able to do it. So we can only really start using this result here from part 4. There's no point really using this because this expression here has got 3 terms in it, so does this. So the only thing we can really do is replace a4 with a squared b squared. Okay, we can replace b4 with, it can be either that one or this one, but we'll replace it with b squared c squared. And we can replace c4, sorry, I should have written this really the same way as that, replace c4 with c squared a squared. So that's what we're going to do here. So we're going to start off with this. So we're going to get that a squared b squared plus b squared c squared plus c squared a squared. Now we know that a4 is a2 b squared. So actually, what we notice here, rather than say, I suppose we could say replace, but we'll notice here that the a4, you've got A4, B4, C4, and the pattern that you end up here with is A4, then you end up with A squared, B squared, so you end up with the square root of the A4 and the square root of the next term of the B4, square root of B4 is B squared, and from this term you'd get the square root of B4, which is B squared, and the square root of C4, which is C squared. So it appears that, which is why we've replaced those with these. It's like saying that the A4 becomes A squared, B squared, the B4 becomes B squared, C squared, the C4 becomes C squared, A squared, but you can also look at it as the A4 has been square rooted, and then the next term has been square rooted and they've been joined together. So we're going to use that same thing here. So this needs to be square rooted, and then so does this term here, and then they need to be written together. Okay, so we'll have the square root of A squared B squared times the square root of B squared C squared, plus then we'll get the square root of B squared C squared times the square root of C squared A squared, plus the square root of C squared A squared times the square root of A squared B squared. Sorry, hopefully that hasn't run off the page, which means that that's equal to A, then we've got B times B, which is B squared, and then we've got C, plus we get B, and we get C times C is C squared A, plus we get, one sec, just checking that, and then we'll get C, and then we'll get A squared, because it's A times A is A squared B. Okay, and that's well, we're trying to get this result here. Won't be a sec. Actually, we're trying to get this result here. Actually, we're supposed to put greater than or equal to here, sorry, because we're using this result here. So replacing that and using, sorry, equation 4, we get that that is greater than or equal to that, which is greater than or equal to this, actually, which just happens to equal that. That's okay, I'll just write greater than or equal to, which is the same as this, because we've got the A squared BC plus we've got the B squared AC plus the C squared AB. So therefore, we've proven that result. So instead of, because this row actually equals that one, you either put an equal sign here or you write this out every single time. Okay? So therefore, we've proven that result there, and we'll call that equation 5. Now, for part 6, sorry, the last part of the question. So there's another part of the question which I'm about to write down, and it is the following. Don't know if I'm going to fit it on this page, and the question is deduce, but if A plus B plus C equals D, then A4 plus B to the power of 4 plus C to the power of 4 is greater than or equal to A, B, C, D. Okay. I'll just see if I've got room to do it at the end of this page. Now, we can use this from part 5. So equation 5, or from part 3, we know that, what do we know? One sec, I'm just looking for it. Now we know that from part 2 that A4 plus B4 plus C4 is greater than or equal to A squared B squared plus B squared C squared plus C squared A squared. Now that was equation 4, and that was in part 2. So from part 2 we know that, but from part 3 we know that that is therefore is also greater than A squared BC plus B squared AC plus C squared AB. So therefore we can say that A to the power of 4 plus B to the power of 4 plus C, sorry, this is a 4, plus C to the power of 4. So therefore A to the power of 4 plus B4 plus C4 is greater than or equal to this result here. Now we can factorize this, and we know that A, B, C is a common factor. And we've got A plus B plus C. So we've got A, B, C is a common factor there. And we know that a plus b plus c is d, so therefore we've come up with our result that a4 plus b4 plus c4 is greater than or equal to a, b, c, and a plus b plus c equals d from the question. So therefore we've ended up with the result that, because we're subbing in a plus b plus c equals d. Okay, and that last result has been proven as well. Okay, that's the end of that question.